So in the Anaconda folder, you will find Anaconda Navigator. So Anaconda has built a lot of interfaces for Python. One of the interface which we are going to use is the Jupyter Notebook. Because Python is a command prompt based language, we need some GUI to save our code and project in a proper format. For that reason, we will be using Jupyter Notebook as our GUI for Python. There are many of them. You can also use Spider. Once you gain experience and all, you can use Spider. You can once we go to industry, you can use PyCharm, develop deployment industry related ones. There are many products which are created by Anaconda to work with Python. We will be using Jupyter Notebook, not the Jupyter Lab. Jupyter Lab is for Apache Hadoop and cluster-based computing. So there are two Jupyters. We will be using Jupyter Notebook. So click on Jupyter Notebook launch. So it will open a window with your default browser. And the default browser preferably should be Chrome. So in Anaconda Navigator, click on Jupyter Notebook launch. It will open in the default browser. Preferably the default browser should be Google Chrome. If it is opening in Internet Edge, later you go to settings and change the default browser to. On the right side, you can see new. Click on it, it will open the new Python notebook. So first create a folder. New Python 3 will open a Jupyter Notebook, which is a cell-based environment. New Python 3 will open a Jupyter Notebook. Click on new folder. It will create an untitled folder. First, scroll down, you will see untitled. Scroll down, you will see untitled. When you click on new folder, it will create an untitled folder in the home page at the bottom. So when we look at the Python, Python is the preferred language for data science. It has utility in other fields also, but predominantly it gained prominence for use in data science. The Python data structures which we need to understand for data science are, the first one is list or array. List or array. This is the fundamental data structure of Python. List or array and where and elements separated by. So anyway, I'll share the notes with you in a PDF file as well. So if you're not comfortable in typing, please don't type, write it in a pen notebook. So list or array starts and ends with square brackets, and elements in the list are separated by comma. List or array are mutable or appendable. They are unordered, duplicates, and multi. Mutable means you can edit them. Mutable or appendable means you can edit. You can edit means you can add, delete, remove, insert anything. Num array is equal to 24, 78, 12. Similarly, character array is equal to, you can use double quotes or single quotes, mixed array, print, mixed array. Okay. So arrays or the list are the fundamental data structure. Even if you give data in the form of a table or a data frame, in the back end, Python will break them into arrays or lists. And then these arrays or lists are used for computation. The output of any computing process will be a set of arrays or lists. Whenever you do any computation, you get the output as an array. Arrays or lists start and end with square brackets, elements separated by comma. They are mutable, editable, appendable. They allow duplicates. They allow multi-data types. Hello? कहाँ पे मैं नहीं आप ऊपर आओ थर्ड फ्लोर पे आ जाओ रिसेप्शन में दे दो तो आप केफ एक्लेट बिल्डिंग में हो ना केफ एक्लेट थर्ड फ्लोर पे रिसेप्शन पे दो the second type of data types is tuples and round brackets are called as parentheses and elements are separated by. Tuples are immutable. You cannot append them, you cannot change them, are immutable and allow and multi data types. So I didn't give duplicates here, right? So let us give duplicates. So tuples are immutable. You cannot edit them. You cannot append them. Num tuple, we do the same data from the top. The next important data type is sets. Start and end, curly brackets, and elements separated by or appendable, and do not num set is equal to. Type and run these things. Type the list and print, not the one with the hashtags. One with the hashtag is notes. Type the multiple lines. If you're printing multiple outputs, you have to use print. See, there is an Anaconda folder. This is the navigator. So you click on this icon, all apps. Once you go to all apps, you will see Anaconda folder. In that you click on navigator, it will open. Of dictionary are key. Key is the character data and value is dictionaries. Start and end with curly brackets. The inputs are key value pairs. Dict 1 is equal to 1, comma, email 0. Key is character, value is the number. For copying the image, once you select the image, right click, copy in the image, go to the cell, click on cell, right? And then you paste the link and shift enter. Shift enter is the keyboard shortcut for running the cells. You'll get the picture or images. So I will be sharing the notes, pictures, images, formulas. So if you want to paste the image, first get the image from Google, right click, copy image, and then convert the cell. You have to go to cell type, markdown. Convert the type to markdown, then paste the link, and then shift enter will give you the image in the notebook. So I'll be giving you the formulas and all which are required in the form of images like this. So these are the differences between list, set, and dictionaries and tuples. Okay, all of you got the dictionary notes. This is the dictionary notes.
Process of adding the image once again.
So for adding the image, first you need to convert the cell. First, you have to convert the cell to markdown. Markdown means you will not see square brackets next to the cell. Then you copy the image link, right click on the image, copy image. Go to the image, right click, copy image. It will call it copy the image link. And then you paste it in the markdown cell and then shift plus enter. Cell type to markdown. See, images, these notes I will share with you. So don't worry about the image and all. I will be sharing the notes with you as PDF file and also as a Python IPNB notebook. List or array methods. What are all methods you can implement on list? Num array dot append. Multiple arguments have to be given in square bracket. Print num array dot count. Oh, we have to give the argument also. So 20 is coming 2 times. 20 is coming 2 times. Count, you give the input, how many times it comes. Num array dot index. Index of 20 is 9th. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here you have to remember Python starts with, so when you're counting, you should count from 0. Index position. Print num array dot insert 5, 88. Sorry, 88, 5. Why it is doing none? I and the element. So inserted 5. Acha, 88 is inserted, na? It is inserted, right? 88, 5th position. So num array dot sort is doing ascending order sort. So clear elements of the list. Num array dot pop. So element 6 is pop will remove at a specified position. The specified value is removed. Actually insert, it inserted 88 at a specific location. Element at specified position, insert. मैं वो नहीं होगा बोला था कल परसों में आपके कोई बंदे ने चेक किया वो नहीं होगा. Too many obligations अभी नहीं होगा. This is cell. That is the output. So these are the basic data structures we will use in data science. There are other data structures also, but these are the ones which we are concerned with data science. Now let us look at the libraries. So the libraries which are very important when you start any Python data science project. The first and foremost is pandas. So pandas is a data frame based resample. Pandas is a library in Python that deals with data frame based operation. Data frame, as I told you, by default, rows are observations and columns are also called in Excel. So pandas is a library we need to import the data into Python. Because most of the time data will be in CSV files or Excel files or tab separated files, or it can be HTML file, it can be a JSON file. Any type of file you can import into Python using pandas library. It has a lot of functions predefined that will allow you to import data of different types. So pandas is a very library. It has additional functions also. If you want to perform operations on a data frame, concatenations or merging or joining, reshaping of the data frame, replacing of values within the data frame, splitting columns, combining columns, all these operations you can do using Pandas library. Pandas library also has the date functions. If at all you're dealing with dates, by default, date will not be read. You have to format the date, then only it will be read as, even the date is in the predefined structure also, Python will not read it as date. It will take it as object. You have to redefine the date. You can do it using Pandas library. So Pandas is the primary library which we need for doing data frame based operations. The second library which is very important is matplotlib, matplotlib.pyplot. This is a data visualization for creating and most importantly resizing the plot window, axis labels, what we call so whatever changes you want to do to plot window, that can be done using this matplotlib. Because in Pandas also we have plot. You can do graphs and plots using Pandas library also. But you cannot adjust the plot windows. Suppose I want to expand the plot window, height and width of the plot window. Then we have to use matplotlib library. I want to reduce the font size of the title, matplot library. I want to add x-axis label, y-axis label, matplotlib library. So matplotlib also has visualizations with all the operations to be done on the chart, like adding data labels, resizing the plot windows, all those things you need matplotlib. Pandas also has plots. Pandas also have plot function, but you cannot alter the plot size. You cannot alter the plot size. Sometimes you have to expand the plot. If you have too many levels in the variable, you are trying to do a bar chart, you have to expand the plot size so that all the bars are plotted clearly with all this. So matplotlib.pyplot is a library for data visualization. We have other libraries also for visualization like Seaborn. Seaborn is also there, which is exclusively visualization library, which is less code intensive compared to matplotlib. Compared to matplotlib, Seaborn is less syntax oriented, but Seaborn is also built on matplotlib only. And third and the most important library is NumPy. Array or list based NumPy is for array or list based operations. All computations and calculations are performed by this library. In Pandas, you can only adjust the data frame, you can do all those things, resize, what you call reshaping, resampling. But if you want to implement a mathematical function, you want to implement a statistical function, or you want to do an algorithm like linear regression, you need to have NumPy library. NumPy library is the computational library of any basic computation to advanced computations. NumPy is the library that will do the computation. Sub-libraries in NumPy, which are very important for us, NumPy is a very, very large library in Python. It has functions related to statistics. It has functions related to machine learning. It has function related to astrophysics. It has function related to biochemistry, physics, geometry. All different functions are available in NumPy with different sub-libraries. Now, the sub-libraries we are concerned is scipy.stats. This is for statistic scipy.stats. This is a sub-library. So once you import NumPy, all these libraries are automatically imported. All the sub-libraries are automatically imported once you import NumPy. Second one is stats models. This is for time series IoT data, Internet of Things data. IoT data is data collected through sensors, and it has time variable, right? Timestamp will be there. So stats models is for that. And the most important for us is sklearn, which is the core library for machine learning. This is the core library for machine learning in Python. Also called as scikit-learn is the core library for machine learning in NumPy. It has all the functions that are required to pre-process the data and to run all the machine learning algorithms that are available in Python. Right from regression algorithms, classification algorithms, clustering algorithms, any algorithm which is there in Python, it is there in sklearn. You have all those algorithms in sklearn. Sklearn is the core library for machine learning in Python. Now, these three libraries we need to import. We need to import for any data science project. One more library which we need is IO, output library, working directory. We also need this library to set up working directory. Working directory means a folder will be, the path of a folder will be set, and all your outputs, all your inputs will be in that particular folder. Your data sets which need to be inputted, all will be in that particular folder. Okay, so working directory means a folder where you will have your data set. Whatever outputs you are writing will automatically stored in that particular. So it is like working directory. Because in industry, you will be importing multiple files. It will not be a single file which you are working like this. So we can't import one by one, right? So we have all those things in a single directory, and we will write a simple for loop wherein we import all the files from the directory in one single. So working directory setup is done using IO library. Now, other libraries to be installed as we go through the curriculum. These libraries will not be there in Python, Anaconda Python. We will be installing as we go through the curriculum. The one is NLTK, text block. This is for natural language processing. For NLP and natural language processing, we will be using this TensorFlow, deep learning, and image processing. So the other libraries, as we go through our curriculum, we will be installing these libraries as and when required. Whenever you start, this is the starting point. Import pandas as PD, numpy as NP, dot pyplot as PLT, and the fourth line to see the graph immediately after the cell, matplotlib inline. This is the first thing you need to type whenever you start your Python project. Import pandas as PD, import numpy as NP. We are giving short name because the syntax is lib name followed by the function name. Library name dot function name with parenthesis is the syntax. So we are giving short name to library so that we can refer to them with the short name. Import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT, percentage matplotlib inline to see the graph immediately after the cell. Meanwhile, we have typed these guys, created, I think you already have created a folder, right? Where you have saved yesterday's New York data. Let me just download the New York data. I don't have the New York data. 1 second. Then I will move the data to my default folder. Downloads to. So to set up the working directory, first right click on the folder, properties, right click on the folder, properties. If you go down, you'll have properties, right? Click on properties. In properties, go to security tab. In the security tab, you will see the complete path of the folder. C:, the complete path of the folder will be there. Copy the whole path. Right click on the folder, go to properties, in properties, security tab. Whichever folder you have saved the data, whichever folder you have saved your data, right click on the folder, properties, last will be properties, and in properties, security tab. In security tab, object name will be there where you will see the complete path, C:, and all. Copy the complete path. So import IO, %CD, Windows laptops, double quotes. Yeah. No, that yesterday you guys said it is not possible. It will not be done. Too many applications. No, that also not possible. Hey, %CD, double quotes. Windows laptops, %CD, space, double quotes, and then paste the path, and then shift plus enter. You should get the path as the output. Right click on the folder where you have saved the data, properties, security tab, object name, copy the path, C:, copy the path, import IO, %CD space, double quotes, and paste the path, and shift enter. The output will be the path. See, sometimes if you copy additional spaces, it will be the problem. Copy the exact path. We're trying to build a direct form. No, don't copy the file text. Copy the except invalid syntax. So it is asking you to use this path. Move the folder to that. Only folder I was using the file name. So it is saying use this path. You put the folder there and then do. Is equal to pd dot. Our format is Excel file. Generally, we use CSV files, but today we will be using Excel file. read underscore Excel. See, for autofilling, type the lib name pd dot re and tab. Press the tab. First two letters of the function and press tab, autofill will start. Read underscore Excel, double quotes, New York Airbnb dot XLX, comma, sheet underscore name is equal to, what is the sheet name? Because we have worked on multiple sheets, right? So we need the sheet name also. So sheet name is New York Airbnb. I think I have to close the sheet. Okay. So what's the problem? See, generally we will be using CSV files, comma separated files. Read underscore CSV. Read underscore CSV is the file format which we generally use in data science. But this is an Excel file. We have already converted it to Excel. I sent you the Excel file yesterday. In Excel, we will have multiple sheets. The data sheet name is New York Airbnb. So if you are looking at the syntax, PD refers to library name, read underscore Excel is a predefined function. Every function must have round brackets, will be null. So the standard syntax is library name. 2 days back, I have applied something online. I didn't get any response till now. So the standard syntax is library name dot function name. Library name dot function name followed by parenthesis. Every function must have parenthesis. You can also use data frame based function syntax. No, I don't have salary slip. It did with some Perfios or something, no? That he said verification is application is completed or something I got. I don't have a salary slip. Then which then in the process I would not have continued. I'm a trainer, freelance trainer. Work for a company called Maticus. Not own. I work for a company called Maticus. Safest position is always don't put it as given name. Rename it as data sets or Python or something. In the file name. We can also use data frame name dot function name followed by parenthesis. So we have assigned a data frame name called NYBNB. NYBNB is the name of the data frame. We have assigned. When you are importing, you always need to assign a name. It can be alphanumeric or it can be an alphabet also. D is equal to your class. But the best practice is whatever the data represents, that name should be given. Or you can simply say D is equal to A is equal to, and you can give the function and then the file name and all, you can import it. So all of you have imported the data. So there are two methods, libname dot function name or data frame name dot function name. Predefined functions. Every predefined function must have parenthesis. That's compulsory. Either the brackets will be null or you have to give arguments within the brackets. Now, to see the data what we have imported, we have an interesting function called dot info. Data frame name dot info. Data frame name dot info. Info is a function. Yes. Tell me. Friday, what time? No. So not third, no. It will be what? 10th of February, no? Yeah. Okay. Yeah. So the info output is very detailed. Machine and put in that. So you can see here, it's a data frame. Number of rows is 41,533. Number of variables is, so it is giving you the class is data frame or the structure is data frame. Number of rows is 41,533 or rows or observations, columns or variables. And then it is also giving you the individual variable data type. Int 64, float 64, 64 NS is another type we generally see. See here, date time 64 NS, int 64, float 64, date time 64 NS. And non-null count a variable missing values. The non-null count will tell you whether there are missing values in the data or not. So you can see here, name column has missing values because it is less than 41,533. Similarly, host name, there are missing values because it is less than 41,533. If the count is less than 41,533, that means that cell has missing values. Look at last review. Almost 9,000 missing values are. Here also 9,000 missing values are. So the null count will give you whether there is a missing value or not. Int 64 is whole number, float 64 is decimal. Int 64 is whole number. Float 64 is decimal. Both of them can be called using number. Object means string or character. Object means string or character. Date time means date format. So info gives us a very good information of our data. Info gives a very good information of our data with all variable type, size, what type of data you're dealing with. All the information is given in your info function. Number of variables. 1, 2. How many variables are there? 4, 12, 18. 6 object, 8 integer, 3 float, 1 date time. Indexing or accessing specific rows or columns. One of the critical tasks of data science. We have character indexing, accessing by name must exactly match. Numeric indexing by column index number. So when you're counting, you should count with. So there are two types of indexing: character indexing and numeric indexing. Accessing specific parts of your data frame. Accessing specific parts of the data frame. In character indexing, the name must exactly match. In terms of font size, special characters, everything, it should exactly match. Character indexing. Data frame name, dot, column name, data frame name, single quotes or double quotes. If the variable name has space in between, you have to use square bracket, double quotes or single quotes, and then the variable name. The variable name must be given in single or double quotes. If there is no space, you can put full stop or dot and then give the column name. Okay. Take for example, NYBNB dot price dot head. Head gives you by default 5 rows. Head will give you by default first 5 rows of data. Data frame name dot column name, and we applied a function called head. We got the output. These are the first 5 observations in the column called price. And the data type is, so same output can also be got using NYBNB square bracket, single quotes or double quotes, price. You'll get the same output. Data frame, you're slicing or subsetting the data. Subsetting the data. For subsetting data in across programming languages, it's square bracket.
Want to use any column within a table?
Subsetting means, yeah, you are trying to access only the column called price. Start using the tab. First 2 letters, press tab. First 2 letters, press tab. Tab on your laptop, autofill, right? 90% are spelling mistakes. To avoid them, type the first 2 letters. See here, NY tab, and then press enter. PR tab. Choose enter. Dot HE tab. That way you will eliminate all the spelling mistakes. Now, multi-column character indexing. Character indexing, multi-column. In the earlier case, we are looking at only one column, right? For multi-column, data frame name followed by double square brackets, var1, var2. Double square brackets. One for subsetting, one for multiple arguments must be given in list. NYBNB, double square bracket, single quotes, price, comma, minimum underscore nights, number underscore of underscore dot head. If you want more than 5, you can give like this, head 10. This will give you the first 10 rows, double square brackets. Double square brackets. Remember this, we constantly choose columns. This is character indexing, indexing by name. 4 o'clock, let's take a break for 15 minutes and then we'll come back. And then we'll do numeric indexing. All right, numeric indexing. So price is name 9, index location, dot iloc, index location, colon, comma 9. Colon, comma before indicates column selection or variable selection. If you don't give colon, comma before, it becomes row selection. So colon, comma before is column selection. If you don't give colon, comma, it will become row selection. This is the data of row number 9. Row number 9 is this. Numeric indexing, New York BNB dot ilocation, square bracket, colon, comma, square bracket, 9, comma, 10, comma, 18, dot head. Positional index out of bound, okay, not 18. Or you can give like this also. 9, colon, 11. Oh, it's not taking column, huh? 9, 10, 11, 14, and 17 columns. Row number 9, 10, 11, 14, and 17. In the earlier case, columns. Here, rows. So I understood indexing, character and numeric, very important. Selection of columns we constantly do. You constantly subset columns, select specific columns. Earlier it was called index loc, now it is called ILOC, ILOC. Exploratory Data Analysis, EDA, which are descriptive data visualization and data aggregation or grouping, complete understanding of data. The first one is they describe on numeric variables. We call them as univariate. Descriptive statistics on numeric variables. We call them as univariate statistics, all single variable. Measures of central tendency being midpoint. Measures of scattering of observations. The measures are variance and standard. Measures of location and deciles. Measures of asymmetry means how close data is normal distribution or well. So these are the measures of, these are the descriptive statistics, also called as univariate. Mean and median must be closer to one another as mean gets distorted or large. So mean and median must be closer to one another because mean gets distorted by smaller values or larger values. If mean is distorted, median must be, you will take median, not the mean. Standard deviation, and it does not have a fixed range, and it depends on the mathematical unit. Positive skewness, peak of curve is on left side, and negative skewness, the peak of the curve on the right side. Left side is positive, right side is negative. Skewness. Similarly, positive kurtosis indicates tall and narrow, and negative kurtosis flat and negative. It is treated as negative. Less than 3 is negative, greater than 3 is positive. This is the skewness and kurtosis. Positive, 0 is normal distribution, is equal to 3 kurtosis is normal distribution. Negative, and this is positive kurtosis. This is negative kurtosis. Flat and wide peak is negative, tall and narrow is positive. Skewness and kurtosis. So this is the interpretation of your descriptive statistics. You need to look at your descriptive statistics and understand these parameters: mean, median, standard deviation. Descriptive statistics sometimes doesn't give skewness, kurtosis. We have to calculate them. They are bivariate. They are bivariate statistics. Now we are talking about univariate statistics as of now. Once we complete univariate statistics, then we go into bivariate. These are univariate, single variable. These are calculated on single variable. Only on numeric data. Only on numeric data. Now the function in Python is described. The function for calculating the descriptive statistics is described. Now we will do it on single variable. PNB dot price dot describe will give you n, will give you the min, will give you the max, will give you the mean, will give you the median or 50%. Standard deviation, you get the 25% first quartile, 75% third quartile. So the describe function, the describe is a predefined function within Python for calculating descriptive statistics. Describe is a function defined for calculating predefined function, and it's a pandas function. It's a pandas function. So you can see the documentation. You type in Google pandas describe, you'll get the complete documentation. So you can see here pandas, lot of functions are there. See, there are many functions which are predefined in pandas, which we generally use in. So lots of functions will be there. Now remembering them, some of the important functions you need to remember. Rest of the things you always have to go through documentation. Documentation is the best place to find the relevant functions. You can search for the function, it will give you the function, usage, and example. So for this data, we are not getting the other two components. The other component, the asymmetry is not there. So we can calculate it. Print nybnb dot price, nybnb dot price. So skewness is 78, kurtosis is 7,498. Very high skewness and very high kurtosis. If you are not sure what is what, you can type. dot skew is the function for skewness, dot cut is for kurtosis. Data frame name dot variable name. Data frame name dot variable name dot function name followed by parenthesis. Parenthesis is compulsory. Either parenthesis will be null or we give arguments. Parenthesis is compulsory for function. That is the default syntax. Every function in Python, predefined function will have parenthesis. Even user-defined functions also, you have to have parentheses. So describe is a function for descriptive statistics in Python. There is some difference between mean and median, right? And standard deviation is also very high. So what do we observe here? Mean and median, and also standard deviation is, so in this case, median is, so mean is distorted. Mean is getting distorted, na? That is why there is a problem. Mean is getting distorted by higher value. In this case, higher value, because max is 98,159, right? So what do I observe from here? The observation says there is a difference between mean and median. They are very different. Now I would have preferred 131 median is there, means I would have preferred mean at 150 or 160. I would have happy with the mean of 150 or 160. But here the mean is 221, which is a larger difference, which indicates distortion. And also standard deviation is very high. I would have preferred a standard deviation of 30 or, but here we have standard deviation of 990, which indicates a very, very, very high standard deviation. And you can also see from here, very high positive, which cannot be corrected also. You can correct also. This also very high positive, very high positive. All this indicates that price is distorted. All this is indicating there is huge distortion in price. Maximum side is causing the problem because max is very, very high. So by looking at the descriptive statistics, you should come with these inferences: mean, median, standard deviation, and skewness and kurtosis. Inference is completely different. Where you have a hypothesis statement, a question will be there that has to be tested. No. That's a difference. There you are validating a data point. Here we are not validating, we are understanding a data point. In inferential statistics, we will validate or we try to prove a statement. Here we are just understanding the data. We are just understanding the numbers, whether they are closer, whether they are far, whether distorted, all those things we are trying to understand. NYBNB, double square bracket, single quote, minimum underscore nights, number underscore of underscore reviews, multiple columns, descriptive stats. You can use all Windows functions, Control-C, Control-V to copy paste the functions. If you are having not comfortable in typing, you can do this. NYBNB dot columns will give you the variable names. Always, if you are not comfortable with typing, print dot columns. So dot columns will give you name of the variables. Okay. Now you can copy Control-C, Control-V, Control-C and Control-V. Select it, Control-C and Control-V. These two are common, right? So you can select them simultaneously, but select them exactly. Okay. Control-C and run this. If you are not comfortable in typing, anytime you are trying to do dot columns. Dot columns will give you the list of variable names. From there, you can copy paste. This way you can eliminate spelling mistakes and all. So use dot columns, print the list of names and then copy from them. I'm telling you again, 90% are spelling mistakes. Please let us use autofill and use copy pasting of the names. That way we will eliminate those mistakes. Okay, dot columns will give you that, and then you can copy paste the function to calculate skewness and kurtosis. Now, till now we have looked at numeric data. Let us look at non-numeric data. Or let us look at univariate plots. Univariate plots, line plots, stacked bar charts. You can do line charts, pie charts, bar charts, stacked bar charts. All those things can be done in univariate plots. So pandas plots, name dot variable name dot plot kind is equal to, you can give anything. Kind is equal to bar comma stacked is equal to. So kind can be anything. Now, apart from these plots, we have three most important plots: frequency distribution table, class interval, and upper limit. And you will have, so histogram is the bar chart of the frequency distribution. In a frequency distribution table, you have two columns, class interval lower limit and upper limit will be there in class interval, and then frequency will be there. Histogram and kurtosis highlights skewness, kurtosis, and outliers also, and outliers. So outliers, I have just explained what it is. So histogram is very, very important plot. What type of skewness you have, what type of kurtosis you have, and whether there are outliers in your data or not. The second plot is box plot based on Q3 and interquartile range. Box plot is based on quartiles. First quartile, second quartile, third quartile, and interquartile range is box plot based on the position of the box, whether the box is on the left side or right side, skewness, and most importantly, extreme values outside normal data range. Outliers are extreme values that fall outside the normal data range. Now, how do box plot decide outliers? Using the formula. On the minimum side, it uses the formula Q1 minus 1.5 times interquartile range as the limit for outlier. So anything that falls outside this range will be considered as on the maximum side, Q3 plus 1.5 times interquartile range. If any observation falls outside this range, will be considered as, this is what I mean by outliers. So this is the lowest point of the data. This is the highest point of the data as per the formulas. See, anything that falls outside this will be treated as outliers. Dot, 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 you will get them as outliers. On the maximum side, oh, this is wrong here. What is this formula? Sometimes it will make Q3 plus, it will be Q3 minus. You have to be very careful in internet. And there will be errors in formulas. Q3 plus 1.5 interquartile range, Q1 minus 1.5 interquartile range. First quartile, median or second quartile, third quartile, difference is interquartile range. The middle is yellow line is median or Q2. Median is also called as second quartile. So this is the structure of box plot. If the box is onto the left side, positive skewness. If the box is onto the right side, negative skewness. The position of the box will tell you what skewness you have. So box plot's primary job is to identify outliers. Along with that, it will also identify skewness. Now the third is based on distribution, shows how close data is to distribution and kurtosis. Density curve is calculated using standard normal distribution formula. The standard normal distribution formula is this. So this is the formula it uses and calculates standard normal distribution score for each observation. 1 by standard deviation into square root of 2 pi into e to the power of minus x minus mean whole square divided by 2 sigma square. So this formula is used and a normal distribution score will be calculated for each observation. And the line plot of that, all those observations, we call it as density curve. And that density curve will tell us whether the data is closer to normal distribution or not. So you will get a density curve like this. See the line, red line you can see here, right? It's called density curve. We used to earlier plot it with histogram. Nowadays we are plotting it individually. Basically, if you are looking at normal distribution, this graph is important. So 68% observations fall within 1 sigma of the, and then 99% of the 99% of them will fall under 2 sigma, and rest of them will fall under. So in relation to box plot and density curve, this is what we are looking at. 68% of the observations will fall under -1 and +1 of the normal distribution if the data is normally distributed. So you can see here, this is the box plot in relation to the density curve, normal distribution, bell curve or normal distribution curve. Just for your understanding, what is the relationship between these curves? So normal distribution, standard deviation curve is very, very important. So these are the important plots we have to do on numerical variables in ML and data science. On numeric variables, we have to do this. Okay. Now let us plot them. NYBNB dot price dot plot kind is equal to hist. See, it's a single bar completely towards the left side. Single bar completely towards the left side. Very high positive skewness. 78 we got, right? Which indicates a very, very high. Kind is equal to hist. NYBNB dot price dot plot kind is equal to comma what is equal to false. See, so many outliers are there. The box is completely towards the left. Even box is not visible because of too many outliers. That too very, very large outliers. What is equal to false? By default, it will give a vertical box plot. To better understand, we are looking at a horizontal box plot. By default is vertical. Kind is equal to very narrow plot. नहीं वो नहीं हो पाएगा. मैंने अपने मैनेजर से बात किया है, नहीं हो पाएगा. कल मेरा रिलेशनशिप मैनेजर, आई एम क्लासिक कस्टमर ना, मेरा रिलेशनशिप मैनेजर से बात नहीं वो नहीं होगा. NYBNB dot number of reviews kind is equal to number of reviews also high positive skewness. Box plot of reviews. You can see the box, but you can see the outliers. Kind is equal to hist, kind is equal to box. No, it's running. What stuck on there? That's something you have to remove it. Positive is clear. With lot of outliers. Because of outliers only the skewness is towards the left. Positive skewness with too many outliers. Very high positive skewness with too many outliers. Now the non-numeric data. Only frequency counts and cross tabulations. For non-numeric data, only frequency counts and cross tabulation. Dot value underscore counts drop NA is equal to false. If you have any missing values also, it will show you. Value counts is the function to find frequency counts. Data frame name dot variable name dot value underscore counts. Drop NA is equal to false means if there are missing values, it will show missing values also. Or if you don't want any missing values to be shown, you can run it normally. Oh, so value counts for neighborhood, we have 223. It is not displaying all. It is not displaying all the rows. So what we have to do is PD dot set underscore option display dot max underscore rows comma 225. Now it will display the complete output. Because of the window size problem, we were not getting all the neighborhoods data. Now, by setting the option of displaying the max rows as 225, now we can see all the neighborhoods data. PD dot set underscore option display dot max underscore rows. Now, if you want only top 20, n largest will give only top 20. You can give top 30, top 40, your choice. N largest will give you the top. So if you want to plot it, dot plot kind is equal to, you can see the top 20 plots bar. Containers. We have to use PLT dot plot. So we have to write a loop. So this is with data labels. DF is the name we are giving to the DF will store the output of this. AX is plotting the function. We are using AX is the plot. And then we are using for container and AX containers, bar labels. So this AX will store the bar data labels in the container. So this is top 20 neighborhoods with data labels. If you don't want data labels, you can just do kind is equal to bar pandas plot will work. But if you want with data labels, we have to do like this. No, we are just giving a name to store the output of the data of that function. It can be anything. So font size 7 is giving us clear labels without any overlapping. Color is equal to orange also is giving us you can change the color of the bar and you can also change the font size and color of see in EDA, visualizations are very important. Whenever you're doing any data project, you have to do a lot of visualizations. See, once you create AX, once you do the bar plot, it will create a container for labels and store it in the form of containers. So this can be anything. For I in AX container, I will also give it to you. So once you plot the bar plot using matplotlib, this is not pandas plot. Here we are using matplotlib plot. In matplotlib plot, once you plot the bar graph, in the backend, it will store the data labels in the variable called containers, right? So till now we were using pandas plots. Here I have used matplotlib plot. In matplotlib plot, the data labels are stored in a variable called containers. And since we have a lot of variables, we are looping over the variables to get the names. And we are adding the font size and the color. When there are categories, then multiple color. So I'll copy the same code down and I'll change the largest to and color to red. and this to lowest properties. Same code you copy and change one single function, everything will be same. That is the top 20. This is bottom. This is the bottom 20. The earlier one was top 20. One single thing, everything is same. This largest will become smallest. So copy paste the code, change the largest to smallest, you'll get the bottom 20 neighborhoods with properties. Wait. Welcome.